Good morning, students. Are you able to see the screen? Abhishek, are you able to see?
Yes, ma'am.
Yes, right.
Yes, ma'am.
Okay, Pam. So today's class will discuss about this architecture of 8085 microprocessor, right? So this before going to the microprocessor, so we'll see that what is a computer, right? A computer is a programmable machine that receives input, stores and manipulates data, information, and provides output in a useful manner, right? Here, this computer, basic computer, which consists of a CPU and memory and IO unit. So in this, there is a diagram you can able to see that. So this is CPU, this is a ROM, okay, memory, ROM and RAM, and IO devices. Okay. So in order to make a communication between memory and IO interfaces, so there is a lines, okay, call it as an address bus and data bus. Okay. So that because in a particular memory, if you want to store the information in particular address, so this CPU will generate the address according to the memory devices used in that one. So but after that is finding that particular address, so data will be stored in the particular memory address. Like that in IO interface also, if the CPU wants to send the information to the IO devices, input or output devices, okay, from the particular address and data, and necessary control signals also generated by the CPU and received from the IO interface also. So this block diagram shows that with the use of a CPU, memory and IO devices, so we can call it as a computer, right? So that previously this basic concepts of microprocessor, right? So the CPU is a microprocessor. This microprocessor is a programmable machine, and the two principal characteristics of the computer or a microprocessor is response to specific set of instructions in well-defined manner. It can execute a pre-recorded list of instructions. So which means that, so in a CPU, okay, for example, we are going to discuss about the 8085 microprocessor. So for this 8085 microprocessor, some specific set of instructions, there is already defined instructions are stored in that one. So by writing a program in such a way that, so we can execute some specific instructions and we can perform a program, right? So according, for example, if you are going to add two numbers, so according to that, what are all that instructions are required, okay, that instructions should be written. When these instructions are executed by the CPU, so the performance of addition will be doing, right? So in order to, there is already defined, well-defined instruction should be stored in the CPU. The main components of this one computer is a CPU, IO devices and memory devices. And coming to the there is a microprocessor. So this microprocessor is a VLSI chip which includes registers, circuits and control circuit. So there are three major units are there: ALU, and then what is ALU? Do you know what is ALU?
Yes, ma'am.
What is
Arithmetic
ALU?
logic unit.
Arithmetic logic, and then registers and control unit. So this registers which is used for a performance of an in order to, which is used as a temporary registers, right? So for performing, for moving the data to the particular register and adding the data or rotating the data, anything. Okay, so in order to, there is a temporary registers are there, and control unit. So in order to perform a function, okay, in order to perform a particular operation, it may be an arithmetic logical operation in anything, okay, there is a requirement of a control signal is there. So a microprocessor which consists of a ALU, registers and control unit. And coming to the microcontroller, this in addition to the microprocessor, a memory device is also available in a single package, that is called it as a microcontroller, right? Microprocessor which consists of only ALU, registers and control unit, and microcontroller which consists of these additional part, okay, ALU, register, control unit, the memory unit is also there, okay. All these four units are available in a single pack, okay, single IC, we call it as a microcontroller. Here, this is an a microcomputer, okay, a microcomputer which consists of a CPU, input device, output device, and memory. Okay, so and coming to the microprocessor, So we have discussed previously, which consists of a ALU, register and control unit. Coming to the microcomputer, okay, so which consists of the memory, okay, memory processing unit, memory, IO or central processing unit, and then CPU which consists of, okay, so here A to D converter, timer, okay, so everything, all are available in a single IC, we call it as a microcontroller. So today's class, let us discuss about this microprocessor. Right? A microprocessor is a programmable, clock-driven, register-based electronic device that reads instruction from storage devices, takes the data input from input unit and process the data according to the instructions and provides the result to the output unit. Right? A microprocessor is a programmable, clock-driven, register-based electronic device. Okay, so already stored information, which will retrieve the information according to the program we have written, and then processing the data, okay, performing any arithmetic logical operations, and store the result either to the output device or it's stored in the memory unit. Right, programmable, perform different set of operations on the data depending on the sequence of instructions supplied by the programmer. Right, so if I am writing a program for addition program, so according to that I have to write an instruction, okay, addition instruction. If I want to performing a there is a program for rotate, okay, rotating a data, subtraction or multiplication, according to that I have to write a program. A sequence or set of instruction has to be written by the programmer or by the user. So when we are executing these instructions as a one by one, so we can able to perform a particular addition, arithmetic operation, multiplication operation, reading the input or writing the output like that. Right. And next one is a clock driven. So here this whole task is divided into basic operation. Okay, so that why there is a requirement of a clock, which is nothing but when you are operating any microprocessor. So we are nowadays we are saying that what is your speed. Okay, so that if you are using a modem, okay, so this is the rate of information we are receiving, like that. So how can we saying that that is nothing but a clock. Okay, so for in case of a microprocessor also, so there is this is also a clock driven device. So for a particular period of time, what will be the operations to be happened? Okay, so that is called it as a clock driven. So that will be decided by the external clock used in the microprocessor. So here in order to generate a clock, we are using a crystal oscillator. According to the clock frequency, the execution of the operation will happen. So if we are using a clock frequency as a high frequency, then the fast execution of operation is very high. If you are using a frequency as a low frequency, according to that there will be the speed of execution will happen. Right. So there is a this is a clock driven. And the next one, register based. So here we are using a register based, okay, which is nothing but a storage element, right? So in order to store the information, receive the data, in order to perform the particular operation, it should be available in the register. Then only the ALU can able to perform the operation, right? And then next one, electronic device. Okay, electronic device is nothing but a fabricated on a chip, right? A programmable, clock driven, register based device, we call it as a IC. Okay, so integrated circuit, fabricated on a single chip, we are call it as a electronic device. So that's why the first line, okay, you can able to see here, microprocessor is a programmable, clock driven, register based electronic device. And then that reads instruction from the storage device, either from memory or it read from the input device. After performing the data, the information can be stored in memory or it can be given to the output device. Here, this is an internal architecture of an 8085 microprocessor, right? So here you can able to see here. Right. So this 8085 microprocessor. So in order to perform the all operations, so we should know that what are all the features of 8085. Right. So this 8085 processor which was developed by Intel. Okay, Intel 88, Intel company. That company only first introduced this microprocessor, and then this is an 8-bit microprocessor which can accept 8-bit data simultaneously. And you might have studied MIPS processor, right? Have you studied MIPS processor? How many bit processor is that? Can you tell? MIPS processor. That is a 32-bit processor, right? 32-bit processor. Okay, so how we are saying that 32-bit processor? Okay, so it can receive the information. 32 bits of information can be received and perform any addition operation, multiplication operation, and store the result as a 32-bit. So like that, here this 8085 processor is a basic processor which has been initiated, that is initially used in that all microprocessor or electronic devices, which is a 8-bit microprocessor which consists of a 8-bit data line. It can accept the data, 8-bit data, process the data, and store or give the result as a 8-bit. That's why we are saying that this is a 8-bit microprocessor. Okay, is it clear? Why we are saying that it is an 8-bit microprocessor? It consists of 8 data line and all the internal registers used in this microprocessor which can able to store as a 8-bit data. And then microprocessor, this ALU unit can able to perform the 8-bit operation and gives a result as a 8-bit data. That's why this microprocessor is called it as a 8-bit microprocessor. So you will study 8086 processor also. So this that 8086 microprocessor, we call it as a 16-bit microprocessor, which means that it consists of 16 data line, all the registers used in the ALU unit, okay, able to store 16-bit data, right? So why any processor can be called it as a 8-bit processor, 16-bit processor, and then 32-bit. Okay, all the microprocessor, the data lines which will be increasing in numbers of 2 power n, right? So here 2 power 3, 8-bit processor. Then adoda multiple 2 power 4 pathina 16-bit processor, 2 power 5, 32-bit processor, 2 power 6, okay, 64-bit processor, like that. That is, it will be increasing in the way of in powers of 2. Okay. Then here this 8085 microprocessor which operate in plus 5 volt DC supply, and here this will be designed using NMOS technology. Inside of this microprocessor, there are 6,200 transistors on single chip, and it provides an on-chip clock generator. Hence, it does not require external clock generator. And then this operates on 3 megahertz clock frequency. It is an 8-bit multiplexed. Okay, I said that no, this microprocessor is a clock driven. So this minimum clock frequency to be given to this microprocessor is 3 megahertz clock frequency. Okay, so according to that, the speed of the operation will be there. And 8-bit multiplexed and address and data, which reduce the number of pins. Okay, I'll explain why it is we are using a multiplexed address and data bit. And it consists of a 16 address line. Hence, it can address 2 power 16. There is 64 kilobytes of memory. Have you heard that why we are how we are achieving this 64 kilobytes? Abhishek, can you tell? Do you know that how we are achieving it? Abhishek?
Yes, ma'am.
Do you know that how we are getting it 64 kilobytes? Or otherwise I will teach you.
Okay, ma'am.
Okay.
No, ma'am.
Okay, I'll tell you. Right. So
Okay.
here we are having a 2 power 16. I said that no, there are 16 address line. Any memory capacity of a device, okay, it is a memory device or a processor, that memory capacity will be decided by the number of address lines used in that one, right? So here how many address lines I told you? There are 16 address lines are
16.
there. Yes, 8085 16 address lines are there. So this 16 can be, we can write it as a 2 power 10 into 2 power 16. So So 2 power 10 into 2 power 6, right? So what is 2 power 10, pa? Do you know that? What is 2 power 10?
1024.
1024. 1024 is equal to 1024 is equal to 1, right? Do you know that 1024 bits is
Yes,
equal to
ma'am.
1
Equal to 1
kilobyte?
kilo.
Yeah. And then what is 2 power 6? What is 2 power 6? 64. Is it right? 64. 2 power 6 is 64. Then, so this is 64 into 1 kilobyte. So we can call it as a 64 kilobytes of memory. Right? Is it right? Are you able to understand?
Yes, ma'am.
Yes. So for example, if a processor which consists of 20 address lines are there, what will be the memory capacity? Pa? So if we are having a 20 address line, so we can write 2
Can
power
you?
10 into 2 power 10. இப்படி சொல்லலாமா?
Okay.
Right?
Yes,
So
ma'am.
this is 1 kilobyte. This is also 1 kilobyte. So that is, we can say it as a 1 MB. Right? So if any microprocessor which consists of 20 address lines are there, the memory capacity will be 1 MB. Right? So here in 8085 microprocessor, we are having 16 address lines are there. So we can have a 64 kilobytes of memory. So this is an important thing. Okay. So which will be asked in that is questions, it will be asked what is the memory capacity of a particular memory device. For example, if I am having 11 address lines of a EEPROM, what is the memory capacity? Pa? Can you say that? I have 11 address lines are there. What will be the memory capacity?
2 power 11. 2
2
power
power 11,
10.
which can be written as 2 power 10 into 2 power
2
1,
power 10
right?
into 2 power 1.
Then what
Yes,
will be the memory capacity?
1024 into 2,
2 kilobytes.
2 QB.
Right? Which can be written as 2 power 10 into 2 power 1. 2 power 1 is 2. Right? So this 2 power 10 is 1 kilobyte. So we can say it as a 2 power 2 kilobytes. Right? If it is a 11, 12 address lines are there, what will be the memory capacity? 12 address lines are there, what will be the memory capacity?
2 power
2 power 2 9 power 4 kilobytes.
4.
Right? Right? So
Yes,
4
ma'am.
kilobytes of memory. Now are you clear? If I am giving a number of
Yes,
address
ma'am.
line, you can able to find the memory capacity. This is a
Memory
very
capacity.
important question which is asked in microprocessor as well as a digital also. Right? So this is the thing. Right? The screen is displayed.
Yes, ma'am.
Yes, yes, right. Here it is given. Okay, it is given here. There are 16 address lines are there, hence it can address 64 kilobytes of memory. Right? It generates 8 IO addresses. So there are 256 IO ports are there, and then it consists of 5 hardware interrupts: trap, RST 6.5, 5.5, and then 4.5 and 7.5, and then INTR. Okay, INTR is there, right? So it provides a DMA. What do you mean by DMA? Can you expand, Abhishek? Can you expand what is DMA? Have you heard this one?
Direct memory access.
Direct memory
No, ma'am.
access. Yeah, right. So this is a direct memory access. Okay, so which there is a, whenever any there is a, when the microprocessor is connected with the slow peripheral device, so in order to transfer the data to the slow peripheral device, that entire time of the microprocessor will be wasted. In order to save that time, there is a time of the execution time of the microprocessor, so we are going for a direct memory access. Whatever information to be given to the output device or a slow peripheral device, all this informations or data can be transferred to direct memory access. Okay, so this DMA, will take over that and transfers the data to the slow peripheral device. So that time this microprocessor can go for another execution. Okay, is it clear? What is the use of a DMA? When
Yes,
microprocessor
ma'am.
is to transfer the data to the slow peripheral device, that the entire time of the processor will be wasted by transferring the information to the slow peripheral device. That time the microprocessor can transfer the data to the DMA, then the DMA will take over the transfer of data to the slow peripheral device. So after that, this microprocessor will be relieved from that data transferring. It can go for doing its own work like that, right? So that is also available in that 8086 process, sorry, 8085 microprocessor. Okay, so this is an architecture of an 8086, sorry, 85 microprocessor. So I said that no interrupts சொன்னோம் இல்லையா? So there are 5 interrupts are there. Okay, there is trap. So here trap 7.5, 6.5, 5.5. Do you know what is RST? Can you tell what do you mean by RST?
No,
RST,
ma'am.
RST na restart, right? Restart. Okay. And then INTR, interrupt request, INTR. Okay. So these are all that important things. Okay. We can expect a questions. Okay. How many interrupts are there in 80, 86, 85? There are 5 interrupts are there, right? Trap, then RST 5.5, 6.5, 7.5, and then INTR. And there are 2 serial ports are available. Serial in data, serial out data. And coming to this one, there is ALU. So in ALU, what it is specified? 8. What do you mean by 8? Can you say what do you mean by 8 there? I already told you. So ALU,
8 bit.
8 bit, right? So ALU,
8
the
bit.
capacity of storage capacity of this ALU register is 8 bit. And you can see here accumulator is 8 bit, temporary register is 8 bit, and flag register is 8 bit. And you can see here, this is a register array. Okay, so this is a register array. B register is there, 8 bit, C register, and D, E, H, L, right? So there are 6 general purpose registers are there. So simply we call it as a GPR, right? So GPR, general purpose register. And we are having a stack pointer, which is a 16-bit register, and a program counter. Okay, so these two are special registers here. So this is also a general purpose register. So which is whose capacity is 16-bit register. Okay, so and then next one here incrementer decrementer, that is also a latch in solron. So here that is also a 16-bit. And address buffer, okay, so that is 8-bit address buffer. Rend address buffer irukku, because here we are having a 16 address lines irukanaala. So there is an lower order address line AD0 to AD7. Address and data are multiplexed, and A8 to A15. Okay, this is called it as a higher order address line. This AD0 to AD7, that is called it as a lower order address line. So that totally A0 to A15, there are 16 address lines are there, and D0 to D7, 8 data lines are there, right? And coming to this one, this is a timing and control signal, right? So this is this plays a very important role is there, right? Because according to that, for this particular time which is to be generated, you might have studied opcode fetch. Okay, read opcode fetch, and then decode instruction, and then execution, like that, right? So at what time a fetching operation to be happen, and then execution to be happen, and there is a reading operation, right, like that. So all these things that will be decided by the timing and control circuitry. So in order to make this thing efficiently, so there is a clock generator. Okay, clock signal will be there. And then here you might have, what is this x1 x2, what is that? I will remember that. What is that x1 x2? x1 x2 na enapa? You don't know. Okay, crystal oscillator, right? So this is crystal solrone, and you might have studied in electronic circuits, crystal oscillator. Okay, so this is a external crystal oscillator that should is to be given, which will decide the speed of operation. And then here there are control signal, read, write, ALE, and then status signal, and IO memory, and DMA signal. DMA signal we are using hold and hold acknowledge, and reset signal reset in and reset out, right? And we have already saying that there is a power supply plus 5 volt that is to be given, right? So and then on the whole I'll explain here this architecture of 8085, which consists of an ALU, which is an 8-bit ALU. So there is an accumulator is there. There is also a 8-bit register. Okay, so that all these things can be connected with this internal data bus, and the general purpose registers are there, BC, DE, HL, and addition to that there are two other registers, stack pointer and program counter is also there, and serial IO control. Okay, so we are using a SID and SOD, serial in data, serial out data. And coming to this interrupt control, there is an 5 interrupts are there: trap, RST, 5.5, 6.5, 7.5, and INTR. And one more signal is there, INTA, interrupt acknowledge, right? So and coming to this timing and control circuitry, so we are having a DMA signal, and then power supply signal, read write signal, status signal, and the clock signal, everything, right? So like that, here this is an architecture of an 8085. This 8085 architecture is a very simple one. So this is an basic thing, okay? So for everything, okay, whatever a processor we have derived, so this is a basic thing. Right? So this is a pin diagram. Okay, so this pin diagram, this is a 40 pin IC. 8085 is a 40 pin IC, so which consists of a here you can able to see. I said that no, there is a okay, here a crystal out, crystal oscillator input, reset in, SID, SOD, and then these are called it as an interrupt signal, and then AD0 to AD7, address and data are multiplexed, and A8 to higher order address line. And here you can able to see here VCC, 40th pin is VCC, 20th pin is ground. Okay, so this 20th pin is ground. And then read, write, control signal, IO memory, ready. So these are all the control signals. And then these two is called it as a DMA signal, right? Here, this is a 40 pin IC. I already told you why there is a requirement of a multiplexed address and data bus. Okay, so this AD0 to AD7, we call it as a address and data are multiplexed. In order to demultiplexing that, so there is a control signal which is called it as a ALE, arithmetic, sorry. Okay, so this address latch enable, okay, ALE is an address latch enable which is used to generate, or there is a differentiate address and data line to split the address and data. So now if you are seeing here, there is a 40 pin IC. If you are having a address pin separately and data pin separately, surely there is a requirement of pins will be more. So in order to reduce the number of pins, so we are going for this address and data in the multiplexed one. Okay, that is why there is a reason behind this 40 pin IC. In order to reduce the number of pins in the IC, we are using this address and data line as a multiplexed one, right? And then next, this is an, I said that no control signals and arithmetic operations, so we can able to perform and or not. Okay, so any arithmetic and logical operations can be performed. Right, so here we are using a registers. Okay, so registers which can are used to quickly accept, store and transfer the data instructions that are being immediately. Okay, immediately. Then there are in 8085 there are 6 general purpose registers are there. Okay, B, C, D, E, H, L. So they can work as a pair. Yeah, I already said that B register is a 8-bit register and C register is also a 8-bit register. In order to make it as a 16-bit register, that can be combined together. So that we can use it as a register. Okay, so there is we can show it as a here. So BC register and DE register and HL register, right? So in order to store a 16-bit data. And in addition to that, there is a accumulator is there, flag register is there, and two 16-bit registers. Only two 16-bit registers available in the 8085 processor is stack pointer and program counter. What is the use of a flag register? Do you know that? What is a flag register? Do you know that? You might have studied flag register. Microprocessor flag எல்லாம் படிச்சிருப்பீங்க. Right. Here, the flag register, which is used to reflect the results of arithmetic operation, ALU operations oda results reflect பண்ணும். Right. So before going to that, the accumulator here used as a 8-bit data storage device. So the results are always stored in accumulator. And in order to reflect the results of any arithmetic logical operation, there is a requirement of flag register. So this flag register may be called it as a PSW, program status word, right? You should note it down that PSW na program status word. So in order to store the results, okay, accumulator results or any arithmetic logical operation results, so there is a requirement of a flag is there, right? So here we are having a zero, carry, sign, parity, carry, and then auxiliary carry flag, right? So here how many flags are there in 8085? 5 flags, okay? You should remember this one, this because this will be asked in the questions. Zero flag, carry இருக்கு, sign, parity and auxiliary carry. Zero flag na, if you are performing a subtraction operation, then if the result is zero, this zero flag will be raised to 1 to indicate that the result is zero. And then carry flag, if you are adding a two numbers, okay, if you are adding a two numbers, when it is exceeding, okay, 8-bit data, then this carry flag which is used to indicate there is a carry is there. And sign flag, if you are performing a operation, okay, so if you are performing a minus b அப்படிங்கும்போது a ஓட வேல்யூ லெஸரா இருக்கு, b ஓட வேல்யூ ஹையரா இருக்குன்னா, then you will get a negative sign. And parity flag, so parity flag, okay, in that one, how many number of even number of ones present, parity, odd parity or even parity. And then auxiliary carry, so auxiliary carry which is nothing but which cannot be sensed by the user. For example, why I am saying this one, in case of a zero flag la pathina, so during that operation the result of the zero flag can be accessed by the user. Okay, I can check, okay, zero flag na check பண்ணலாம், carry flag check பண்ணலாம், sign flag also can be checked, and parity flag also be checked. But in case of an auxiliary carry flag, it cannot be accessed by the user. Okay, so it is a inside one. Okay, so here this auxiliary carry flag will be generated during the addition of 4-bit. Okay, we are saying that ALU is a 8-bit register. So when you are adding a 2 4-bit, okay, then when there is a carry from the first 4-bit to second 4-bit, that time this auxiliary carry flag will be set by 1, right? Or you understand what I am saying? Abhishek, do you understand?
Yes, ma'am.
Yes, right. So this first carry flag, there is a difference is there. So which is for after adding a 2 8-bit number, if there is a excess data, we are saying it is a carry. But in case of an auxiliary carry, when you are adding a 4-bit, okay, internally 4-bit is there. So then if there is a carry is generated, that will be reflected in the carry flag, right? So in case of 8085, there are 5 flags are there, which is used to reflect the results of the any arithmetic operation. Zero flag, carry flag, sign flag, parity flag and auxiliary carry. Among these 5 carry flags, 4 flags will be accessed by the user. They can able to see the results in the particular carry flag, but we can't able to see the result in the auxiliary carry because it is internally used as a carry flag, right? And then interrupts, 5 interrupts are there, okay, trap, RST 7.5, 6.5, 5.5 and INTR. and serial data, input output data. Okay, so we are having SID and SOD, serial input data line, serial output data line. So through this line, the microprocessor can able to communicate with the external devices. Okay, serial data can be read and serial data can be write into the external device, right? And coming to this one, here this address bus has 8 signal lines, okay, A8 to A15, which are called it as an unidirectional, and the other address bits are multiplexed with 8-bit data, AD0 to AD7, which are called it as a bidirectional. Can you say the reason why it is bidirectional, pa? In case of higher order address line,
Both same timeல வந்து அதான் both
oh, it's not like that, because this lower order address line is used for data. So data can be read and write. Yeah. So that AD0 to AD7 address now only address, it can be the output line. But if it here this lower order AD0 to AD7, which is used as a data line also, so that it can be used as a bidirectional. Okay, this is also one important thing. And frequency, I already said that, so 3 megahertz clock frequency to be given, and then there is 6 megahertz, okay, 6 megahertz clock frequency to be given to X0 and X1. So this X0 X1 you have to give a, so here you are saying that X0 X1, okay, crystal frequency. So we have to give an external clock frequency of 6 megahertz. Okay, we have to give an external clock frequency of 6 megahertz, which will be internally divided into 3 megahertz, X0 X1 ku kudukrom. Right, so the clock out, so this is a signal which is used to make a synchronization of the other devices. Okay, we are able to connect multiple devices, memory, எல்லா signal codum same speed to be operated. So for in order to operate in a synchronizing mode, this clock out signal, okay, so this is very important, this clock out signal to be connected to the other devices. Okay, then only the synchronization will occur. Right, so 5 hardware interrupts in 8085. There is a trap. Okay, so hardware interrupts, I said that trap, RST 7.5, 6.5, 5.5, and INTR. Okay, RST is a restart, and then INTR, so that is an interrupt request signal. Okay, so we'll discuss classification of interrupt. That is this is also a very important thing. So first one is a very important, maskable and non-maskable interrupt. Okay, so we'll concentrate on that only. Maskable interrupts. So maskable interrupts are those interrupts which can be enabled or disabled. Okay, so maskable na, the programmer can enable the particular interrupt. The programmer can disable the particular interrupt. And there is a non-maskable interrupt is there, so which cannot be enabled or disabled by the user. Trap is a non-maskable interrupt which cannot be enabled and there is disabled. But remaining four, RST 7.5, 6.5, 5.5, and INTR, that can be called it as a maskable interrupt. It can be enabled or disabled by the programmer. So that is the thing given here. Enabling and disabling is done by the software instructions. So that interrupts are called it as a maskable interrupts, right? So is it clear? There is a next one, list of maskable interrupts. I said that no, RST 7.5, 6.5, 5.5, and INTR, these are called it as a maskable interrupts. And a non-maskable interrupt, so which interrupts there is a, which are always in enabled mode are called non-maskable interrupt. So these interrupts can never be disabled by any software instructions, right? So trap is a non-maskable interrupt. So is it clear now? How many interrupts are there?
5 interrupt.
5 interrupts. Adala 2, we can classify it as a non-maskable and maskable interrupt. So non-maskable interrupt, NMI. What is NMI? Non-maskable interrupt. Trap is a non-maskable interrupt that cannot be enabled or disabled by the programmer. And previously, maskable interrupt, there are 4 maskable interrupt. So that why it is called it as a maskable interrupt, it can be enabled or disabled by the user programmer. So there are four maskable interrupts in 8085, 6.5, 7.5, 5.5 and trap. Clear? Right. And then instruction types. So here there are three types of an instructions types is there. 1 byte instruction, 2 byte instruction and 3 byte instruction. So you might have studied in architecture also, is it right? MIPS processor you
No.
might have studied. Okay, 1 byte, 2 byte chipping. Right? So this 1 byte instruction includes the opcode and operand. For example, if you are seeing that move C comma A, so C is a register. Okay, C is a register and A is accumulator. Right? And add B. Okay, add B na. What will happen in this one? This accumulator content will be added with the B register and the result is stored in accumulator. Right. So for in order to write that is execute this program, so we are in need of a hexadecimal code. Okay, adula pathina 80. So these are call it as an 1 byte instruction. Okay, you can able to see here. So this is call it as an 1 byte instruction. So this is a 1 byte instruction. So when I am going with that another diagram, another slide, you can able to see here. Here. So next one is a 2 byte instruction. So this is consists of MEA comma data. So any data to be given. So there is a requirement of you can see here there is a first byte and second byte, right? And then third one jump 2085. Okay, jump now we have to give a 16-bit address. So there is a requirement of a 3 byte instruction, right? So here in this instruction types there is a 1 byte instruction. Okay, so when there is an operation happens between inside of the registers, move C comma A, move B comma A, add B, subtract B, CMA, complement accumulator. So when these type of instructions are executed, so there is a requirement of only the hex code required code is 8 byte only. So that this is called it as a 1 byte instruction. And coming to the another byte, another type of instruction, MEA comma 05. MEIB comma 10, MEIB comma FF, like that. So for executing this instruction, we are in need of a 2 hex codes are required. So that we call it as a, these are called it as a 2 byte instruction. When you are going for the jump instruction, there is a requirement of a 3 bytes are required. So jump ku oru opcode kudukono. Then 2085 is a particular 16-bit address. So that there also we have to give a opcode. Okay, so this is a this instruction is called it as a 3 byte instruction. Is it clear, Abhishek? Right? What is 1 byte instruction? 1 byte instruction when operation happens between two registers, right? And 2 byte instruction, so when there is a external data is to be given, right? So there is an data, immediate data is given, there is a 2 byte instruction. And 3 byte instruction when you are going to switch over to the particular memory address, okay, 2085 particular address. So there is a requirement of a 3 byte instruction. Jump and call. So these instructions are called it as a 3 byte instruction, right? And instruction sets. You might have studied how many instruction set of instructions. Okay, you might have MIPS la படிச்சிருப்பீங்க. Here in this 8085 processor only we are having 5 types of instruction: data transfer, arithmetic, logical, branching and control instruction, right? So we will see only one for data transfer instruction. Move RD comma RS. What do you mean by RD pa? RD na enna? Can you say what is RD? Abhishek, can you say what is RD?
No, ma'am.
Destination and source.
Okay, ma'am.
Okay, so move rd comma rs. Okay, source to destination, source ngiradhu rs. Okay, rd destination. For example, if I am writing, okay, you can able to see here, move b comma a, which is source, which is destination. You can see here this
B
last one,
destination, A source.
A on the source. Okay, so that is information or data is transferred from A register to B register. So this is called, at the same time A register content will not be changed, right? So that is called it as a data transfer instruction. And then there are another arithmetic instruction, addition, multiply, addition, subtraction, logical, rotate instruction, branching instruction. I said that no, jump, call, idalam branching. And control instructions, which is nothing but, you can say that control instructions, which processor you might have studied, what are called control instruction? Have you studied?
Yes, ma'am.
Halt and return. Okay, halt and return. Halt na, that execution will be stopped. So this is called it as a machine control instruction, right? So are you clear now? Classification of instruction sets la, data transfer, arithmetic, logical, branching and control. Control instruction, which is nothing but which is used to control the machine, right? Machine na halt, return in the mari kuduthomna, that is called it as a control instruction. And then addressing mode. Okay, so you might have studied addressing modes, is it right? Addressing modes you
Yes,
might have
ma'am.
studied in MIPS processor. So to perform any operation, we have to give corresponding instructions to the microprocessor. So in each instruction, programmer has to specify three things, right? Operation to be performed, address of the data, address of the destination result. இப்ப addition, add a comma b அப்படின்னா இங்க வந்து ஆபரேஷன் a. ஓகே, ஸோ அண்ட் தென் எங்க இருந்து b ல இருந்து a க்கு ட்ரான்ஸ்ஃபர் பண்ண destination result, source and destination. Okay, so that is called it as a addressing mode. The way in which we are addressing mode, so it can be classified as 5 types of addressing mode: direct, register, register indirect, immediate and implicit addressing mode, right? Here direct addressing mode, LDA na load accumulator, load the contents of memory location 2500 in accumulator. So what is this instruction tells us? Okay, so we have to transfer, okay, that 2500 is a memory address. Whatever information is available, that is to be transferred to the accumulator. So that thing is given. LDA is the operation, 2500 is the address of source, accumulator is a destination, right? So this is a direct addressing. So we have given the address directly. Okay, so destination source address to direct kuduthittom, destination address is also given directly. Okay, and next one, register addressing, move b comma a comma b. Okay, so here the operation is move, source is destination, source is b register and destination is a. Move the contents of b register to a. Okay, so this is called it as a register. இங்க பார்த்தேன்னா register மட்டும் யூஸ் பண்ணிருக்கோம். That's why this is called it as a register addressing mode. And register indirect addressing mode. So till now we haven't heard about this M. M என்ற வேர்டே நம்ம ரெஜிஸ்டர்ஸே சொல்ல, ஒன்லி வி ஹவ் சீன் அக்யூமுலேட்டர் பிசி ஹெச்எல் டிஇ தான் சொல்லிட்டு இருக்கோம். ஸோ திஸ் இஸ் அ ரெஜிஸ்டர் எம், ஸோ தட் விச் indirectly indicates the HL register pair. Okay, so that HL register pair is specifying some address. Whatever data is available in the particular address, that is to be transferred to the accumulator. So this address is specified indirectly. So that this is called it as a register indirect addressing mode. And immediate. So whenever we are having the instruction MVI a comma 05, move immediately. So 05 is a data. Okay, so immediately moved into the accumulator. So 05 is the source and then a is the rest and destination, move is the operation, right? And then fifth one, implicit addressing mode. So implicit, if the address of source of data as well as address of destination of result is fixed, then there is no need to give any operand along with the instruction. So this is one important part. CMP, complement. Okay, complement accumulator. CMP na compare accumulator. CMA, Okay, complement accumulator அப்படின்னா whatever the content of accumulator that will be zeros into 1 1 into 0. ஸோ இங்க நம்ம எதுவுமே ஸ்பெசிஃபை பண்ணல, ஆப்ரேஷனை மட்டும் தான் சொல்லியிருக்கோம். we are not specifying source destination எதுவுமே சொல்ல. this is a default instruction. ஸோ சிஎம்ஏன்னு போட்டானா அக்யூமுலேட்டர்ல இருக்க கண்டென்ட்டை காம்ப்ளிமெண்ட் பண்ணி அக்யூமுலேட்டர்லேயே வச்சுக்கும். So that is called it as a complement accumulator. That's why this addressing mode is called it as a implicit addressing mode. Right? So then we'll go for the question. Microprocessor is an 8-bit microprocessor designed by first slide we have Intel. Right. So in 8086 16-bit address banks which can address up to 64 kilobytes. And then there are dash general purpose registers. How many general purpose registers are there?
6.
VC, DE, HL. Okay. It is also a 16-bit register, works like stack, which is always incremented or decremented by 2 during push and pop operation. Stack ne vandiruchu. So the answer is stack pointer.
Yes,
and then flag register is an 8-bit register having how many flip-flops? எத்தனை flags பாருக்கு? In 8085 how many flags are there?
5 flags.
5 flags. Okay.
Zero.
Carry, sign, 0, parity,
0,
auxiliary carry.
auxiliary.
Right. Okay. So MVIK, 20F. Fங்கிறது இங்க வந்து hexadecimal சொல்லும். Is an example of what type of addressing mode? What type of addressing mode? MVI வந்தாலே immediate addressing mode.
Immediate.
Right? Okay. And then which stack is used in 8085? That is last in first out. Okay.
Okay, ma'am.
Instruction in the 8085 microprocessor, how many bytes are present? 3 byte, 1, 2 or 3 byte instruction. And then okay. Okay pa. You can stop.
Okay. Thank you, ma'am.
Okay. Gangadharai sir.
Yes, ma'am.
நான் இதை ரெக்கார்ட் பண்ணனும், ஸ்டாப் பண்ணிட்டு நான் உங்களை திரும்ப அட்மிட் பண்ணட்டுமா?
ஓகே மேம். ஓகே ஓகே
ஓகே
ஓகே மேம்.
நீங்க லீவ் ஆயிக்கோங்க.
சரி, ரைட். ஓகே ஓகே ஃபைன்.
அபிஷேக் நீ அப்படியே லைன்ல இரு.
ஓகே மேம்.
Abhishek, you can also leave and join in the same link.
Okay, ma'am.